Hey everyone, and welcome back. The mailman has just been by, and so I'm really excited to share this with you guys. This is from Uni-T, but it wasn't sent by Uni-T, it was sent by Banggood.com. Uni-T did want to send me some stuff, but it never materialized. Yeah, it is what it is. But Banggood sent me this. I'm pretty excited to mess with this. Do you know what this is yet? Okay, first and foremost, this thing is tiny. I didn't think it was going to be that small. So this is my, there's my hand there. Take some measurements in a sec. Got some accessories here. Got a USB wall wart with a European style plug and a American style plug. We're going to use the American style plug here. Seems like it fits like this. Oh, this way. Aha. There we go. Got USB. Got a USB cable with that finishes in a barrel plug. Okay. We've got a one of these BNC type cables to crocodile clip end, which is good. I think this has only BNC outputs. And we've got a BNC to BNC cable, which will be very useful once we get to the testing. Neat. A little documents, download operation guide. Yeah, the downloads will be for another day. This is a first look after all. So this is the UTG962E function / arbitrary waveform generator. So a function generator is sort of like it gives you a waveform in order to pick it up on an oscilloscope or test out things like op amps or all sorts of things like that. An arbitrary waveform generator means you can set sort of whatever parameters you want for that wave. It can look like a square wave, like a sine wave, or it can look like, you know, a single shot of like, say, like a ripple, a big peak, and another ripple. We're going to peel this off here. I wanted to zoom you in for this nice peel, but it won't work if I can't grab it. There we go. Here it goes. Ooh, this is sticky. That's interesting. Almost like it left residue or something. Was I not supposed to peel this? I don't know. Looks cloudy. Anyways, I requested this one because it is the 60 megahertz version. Has 200 megs sample per second, and I want to use this when I do the functional testing of like oscilloscopes and stuff like that. I wasn't expecting it to be this short, so it's not very long. It's only about, you know, something like 17 centimeters, or about 7 inches or so. It's very small, and it lays flat on the desk, which is going to be pretty neat because I usually film top down like this. So let me give you a quick tour around. We've got some buttons here. We cannot tell what they do as of yet because we are not there yet. It's not plugged in. It is a 2-channel, and I do like that it has the dial pad here, so it won't be like just scrolling this wheel forever. It does have a scroll wheel with press, and it's got kind of scroll buttons. Mode, wave, utility. Over on this side here, we've got the 2 outputs, 50 ohm termination resistors included inside. FSK, CNT, sync. I'll have to check the manual to see what that means, but I believe this is to trigger a waveform. On the back, we've got nothing at all, which is what I prefer my devices to have, so I can lay them flat on the bench. And on the other side, we have the on-off switch, the USB connector, because this thing, I believe, has companion software for the PC, and the little barrel jack input. I really prefer it not to have a barrel jack. I would rather it's just powered by a USB cable because, you know, you have to keep barrel jack in stock. But it is what it is. It shouldn't be too bad. So there we go. We just need to plug this thing in and take a look at its functionality. All right, let's get started. Let's turn this thing on. As you can see, relatively quick boot up time. And I want to really talk about what I really enjoy about this interface. First and foremost, the channel 1 and channel 2. It's a little bar up there. But if you look, the channel 1 is all themed in red. So it's pretty obvious here that we're highlighted channel 1. If I swap to channel 2 with the dedicated button, by the way, everything turns blue. So you know you're working in channel 2. There's no confusion on which is which. Channel 1, channel 2. It's pretty neat. Also, there is a backlight on these buttons. And if you click it and then click it again, it turns on the output. And click it again, it turns it off. It's very obvious what is going on. Very nice. Next is you have quick access to all your waveforms over here. We got sine, we've got square. And then what happens is when it goes away like this, you can always just go back to wave to select another wave. So pulse, back to wave, ramp, back to wave, arbitrary. We're going to get into this in a second. Back to wave. So it's actually really easy to navigate. The other thing is the precision at which you can navigate. So here's a sine wave. And if you look over here, we can change the values here. So this is 1.0000000 kilohertz. So we can actually move and go into hertz and down and down and down. So you can see this is 1 millihertz. This is 10 millihertz. This is 100 millihertz. This is 1 hertz, 10 hertz, and so on, all the way up. Like, this navigation is extremely good, and the precision level is awesome as well. You can also dial in. Let's go back to the 1 kilohertz. You can dial in the number here. You go like 1.0, for example, and then here are your multipliers. So 1.0 what? Megahertz. It's like really intuitive. It's surprisingly intuitive, actually. This thing is such a pro tool. So let's change this again. So we're gonna go here, select this. We're gonna go 1 and then kilohertz, and there we go, 1 kilohertz. Same thing for your voltage, amplitude, your offset, your phase. This is all adjustable really easily. On top of that, you can change things like, for example, your amplitude here is peak to peak, but if you hit this amplitude button and you hit it again, you can change it to millivolts RMS. You hit it again, back to peak. Your offset here can be a low offset or a high offset. Neat, huh? Your phase, same deal. You can change the phase percentage. Your frequency, you can change it from frequency to period. Like, honestly, this thing is extremely well thought out. There's also different modes, because you can actually change modulation, AM, FM, or AM. I'm not sure what this one is. I think this is phase modulation, PM, and then FM, and then I think this is, I don't remember what FSK meant, but I did see it in the manual. This thing is pretty awesome, and you see mode is backlit, so you click it again and you get out of that mode. I want to show you something really cool now, is the arbitrary waveform. You have wave files which are already stored on here, and you have all sorts of different patterns. We're going to try them on the oscilloscope a little bit later, but it comes with all these stored patterns, and you can actually store your own patterns. You can put your own things in here, apparently, according to the manual. We're going to do that in the full review. For now, I just wanted to show you this thing is freaking awesome. You know, now that I have it next up to my Rigol DS1054Z, I kind of regret what I was saying about the screen not being bright. It's actually a little bit brighter than the Rigol on top of that. And I've never really had issues looking at the Rigol, so, I mean, there we go. I take that back. Now, This is still set up to the 1 kilohertz sine wave, 1 volt peak to peak, no offset, no phase. And I am just going to turn this on and see what happens. There we go. I guess I was checking 1 kilohertz stuff last time because I did not change any of these settings. I just turned on the scope and away we went. So there we go. Voltage peak to peak 1.01 volts. So it's pretty much bang on. And frequency 1.00 hertz. Or kilohertz, I should say. 1.00, yeah, kilohertz. All right, let's see if we can change this waveform. Oh, instantly, yeah, don't have to do anything. It already sets it all up. Perfect. Now let's see if we can just sort of hit it up to its max. Kilohertz, megahertz, 10 megahertz. Let's go automatic on this one. This is 10 megahertz right now it should be at. There we go. Frequency 10 megahertz. Still 1.00 to 1.01 volts peak to peak. That sine wave looks absolutely perfect to me. Let's see if we can adjust it some more. We're going to move it over and get ourselves 60 megahertz. Oh, a little bit. 61.0. It's just fluttering a little bit. Maybe if I adjust this a little bit. Parameter limited. Yeah, 59.9 megahertz. Don't forget, this is a 50 megahertz oscilloscope, so that's pretty good. And 776, 780 volts. Millivolts peak to peak, so a little bit off on that peak voltage there, but we're over the abilities of this scope. So let's see. I'm gonna adjust the amplitude here. I have it at 5 volts peak to peak now. Let's adjust this one here. I think it's this one. And we got 4.2 volts peak to peak, still at a solid 60 megahertz. Pretty awesome. Let's see if we can change the wave type while the output is on. We'll go pulse. Value is out of range. Oh, that's not good. Okay. Let's see. Let's just lower this 10 megahertz. Oh, look at that. Looks pretty good. I'm going to drop it even more. Let's go. There we go. 5 megahertz. Good. Drop down amplitude, 5 volt peak to peak, that's good. We can adjust our horizontal base here. Take a look at the pulses. Okay, so the pulses are kind of round. Let's see if we can change the rise and the fall times. Oh, don't think I can make it any smaller. Let me see here. No, 15 nanosecond rise and fall times is kind of the maximum, or the minimum, I should say. That's okay. Let's change the duty cycle. Oh yeah, 11%. Let's see if we can get that even smaller. 11% might be the minimum. Yeah, 11% duty cycle. I wish this was a complete vertical line, but 15 nanoseconds is extremely fast, so that's pretty good anyways. Let's see if we can add a DC offset. Yep, there it rises. Oh, past my trigger point there. So if we bring the trigger point up, still triggering, still triggering. Change the voltage scale. Can change the position as well. Yeah, everything is still working as it should. Well, having trouble with the trigger now. Oh, there we go. Triggering just fine. So yeah, this thing is quite useful. Let's see if we can put an arbitrary wave in there. All right, we'll grab a wave file. Oh, yeah. Internal. And look at that. How fast is this going? This is 5 megahertz right now. Ooh, look at that ringing. Neat. Cardiac pulse. Interesting. Bring the trigger down. Beautiful. Look at that. Let's zoom in on our wave a little bit. Crisp, clean lines. This is, I mean, I might be boring you guys, but this is actually really fun. EEG, EOG, whatever that means. So we can trigger just on the peaks there. There we go. Look at that. Oh, this one doesn't quite look the same, does it? Oh, it does. I'm just looking at the wrong phase. This thing is neat. Oh, that should be square waves, though. Let's see. Yeah, I guess the Rigol is working hard on that one. Very fancy. Yeah, this is supposed to be a stair. Maybe we'll drop the... Let's see if we can just drop the speed here and get a cleaner signal. You know what? I'll leave it at 10 because I think the easiest way to do this is to just change the hertz value. Oh, there we go. There we go. In the, let's say, 1 kilohertz range. So that's 1 kilohertz, and we just change our horizontal time base. There we go. Now the Rigol is picking it up, no problem. So I'm not sure if it's the Rigol that was having issues or if it's the function gen, but either way, this is still very impressive. This is a better piece of kit than I've had in my shop before, so that's pretty neat. Let's see if we can try one more type of wave here. We'll go with our square waves. And there, wow, those lines are solid. Let's see here. See if we can measure our rise time. So I could get the cursors out here. Cursor. Let's see if track will work, or auto even. Track. No, it's not able to do it. Manual cursors. Okay, and then you want cursor A. Move that to here. Cursor B. Move that to about there. And our rise time is just about 41 nanoseconds. Something like that. So that's pretty good. I'm liking it. Probably zoom a little bit more here. Yeah. And there we go. This thing's been running for about 15-20 minutes now, and it is getting a little warm, but it is absolutely silent. There are no fans, no active cooling. Maybe like after a certain temperature it turns on, but it doesn't seem to be at the moment, which is pretty awesome. It's really quiet. The Rigol is a lot louder because it has an internal fan. What am I supposed to say about this? This thing is awesome. This thing is way more powerful than I'll ever need, unless I set my mind to actually learning all the extra features it has. If you're looking for any kind of sort of function generator, this one is definitely a recommend. You can even go down to the 30 megahertz version, which is quite a bit cheaper. But I wanted the 60 megahertz because the oscilloscopes I'll be testing go up to even 100 megahertz. So in fact, it's a little slow for that, but I mean, it is what it is. This thing is incredibly powerful for the price. I expected good things when I saw it was Uni-T branded, but I did not expect it to be this good in this small of a package. If there's anything that you saw today that you want me to test in bigger depth, let me know in the comments below. But if you're looking for a waveform generator, I would highly recommend you go pick up one of these, especially from the links in the description. Thanks for watching.